All right, what's up, guys? Ryan from Elevate Cyber here. I have a very interesting piece of content here, a new series I'm going to be starting up. Now, the reason I'm making this is I know that recently a lot of people have been asking about buffer overflows, exploitation, and stuff like that. So I'm actually going back to one of the classics here. This is the Narnia CTF from Over the Wire. This has been really good, I think really good learning here for you guys to do, maybe follow along. And definitely, if you haven't done this challenge before, I definitely recommend it. I haven't even, full disclaimer, I haven't even done the full thing before. I've done a few of them here and there, but I didn't completely finish it. There's only, here, let me pull it up real quick here. There's only 9 levels, so we can work through all 9 of these over time. But today we're just going to be starting off with the first level of this, or I guess really level 0 here of Narnia. I went ahead and SSH'd into the box. I think here I'm in another directory, so I'm going to have to go back a couple directories, and if I go into Narnia, that's where the different files are here. We're going to do level 0. So these are all C files. All these are written in the C programming language. So we're just going to look at Narnia 0.c. See what's going on here. So basically, you have a program here, and if you've never looked at C code before, might seem a little bit confusing, but I'll basically break it down here. These are just your import statements up here. They're just doing the standard input-output, standard library. Nothing too crazy there. And the main function, which every C program must have a main function. Here's where a lot of the interesting code is. So you have a variable created called value. It's the long type. And this is the hex code for a bunch of A's. So essentially, they're initializing the value variable, val variable, to a string of A's. 1, 2, 3, 4 A's to be exact, capital letter A's. This is the ASCII hex code for the ASCII capital A character. But that is it has a 20 character buffer. So the length of this buffer is 20 characters. And so it's going to print out the instructions here, basically, which what we're trying to do is correct Val's value from these 4 A's to dead beef. Oops, not sure what I did there. Basically correct it to dead beef. Now, it'll introduce scanf, which is basically how it takes user input. So we'll be prompted for user input, and it's going to read 24 strings and write it to the address of buffer. And then it will print the buffer and print the value. And if the value, if we can override it in order to be dead beef, then it will automatically spawn a shell for us. Otherwise, it'll just say that we're way off. Well, let's just run this and see what it looks like, right? So the way you execute C files are just like that, just like you would bash scripts. We run that, and now we're prompted, here's your chance, and we just say we enter like a string of A's. I know these are lowercase. So let's do that again with like uppercase ones, just so you guys can see what this would look like here, basically. You're way off, and then you see the buffer is a bunch of A's, and the value is a bunch of A's. So what we want to do, looks like there's 24. This is a vulnerable script, basically. Like this program here is vulnerable to a buffer overflow, where you can actually overwrite in memory. You can overwrite the buffer into like dead beef. Now, the reason that it's vulnerable is the input is going to be a 24 string that you're writing into the memory address of buffer. However, you've only allocated 20 character length for buffer. So you get the 4, you have the 4 bytes to play with, right? So if we maybe do something like, because remember, 24 is the number. So if we actually do, let's see, 20 A's, and then maybe something like dead beef. Yeah, we see that we weren't able to get it. Now, that's also not really what we want here. See, this 0x, what this indicates is it expects it in hexadecimal. We don't want this in ASCII. So we might need to use the echo command here. And then we can actually pass it ASCII values, right? So that's just one thing to note straight away. So what we can do is do echo with -E, I believe. Let's take a look at the man page on echo real quick. Enable interpretation of \escapes, because that's what we're going to want. That way we can write the hexadecimal. So if we do that with the -E flag, then we can say, hey, do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 A's, I do believe. And as well as \. Remember, this is going to look for a little endian. It's going to expect little endian. How do I know this? It's because this is the Linux architecture here. It's typically what it does. That's normally how it interprets it. I believe it's a 64-bit architecture, 32, and basically, yeah, this architecture typically is going to be expecting little endian format. So what that means is, well, you'll see. Basically, what it means is we do X for hexadecimal, EF, because that's the last two characters here, EF, and then the next one will be BE. So X, BE, and then AD. This is a little endian format here, if you're not familiar. And then DE. You see, dead beef, just like that. Okay, we've done that. We'll pipe that into Narnia 0. And so, yeah, with that being said, it looks like it might have worked this time because we don't see your way off message come up. And we do see this kind of binary junk here. So what could have happened here is that it ran it, because we go back to the to looking at the source code here. Once it runs it, there's nothing to tell it to keep that shell open. It spawns the shell, but then it just closes down, right? It exits with this return 0 here. So most likely what happened is we might have actually gotten this right. I mean, obviously we didn't trigger this else statement here. Otherwise we would have got the way off part printed. So that leads me to believe that the if condition was triggered here, and most likely that once it did the get UID stuff here and spawned the shell, that it just exited this return 0. So what we can do instead, a bit of a nifty way to do it, we can actually come here and we can provide a cat statement afterwards. What this is going to do is this is going to persistently keep this open for us. We have to enclose this in, what's it called? In parentheses here. Not parentheses? No, not parentheses. I'm drawing a blank on what these are called. Oh yeah, parentheses. Yeah, parentheses. That's what we want to enclose it in. And so this is basically going to force it to stay open, and it's going to keep like looking for commands that we can concatenate into this program here, right? So it's going to keep looping. Basically, it's going to endlessly loop until we force close it with a Control-C. If we do that, now we notice we didn't bring back our prompt. So let's just run a who am I? And now we see we're Narnia 1. So just like that, we got into the other one there, Narnia 1. You can run ID. We can see we are now as that user. So that is pretty much the first challenge to this one, showing you how to exploit a basic buffer overflow. Now, as we go higher up in the levels, it'll get more complex, more difficult, and there'll be even more to learn. So if you've been enjoying this content, definitely be sure to subscribe to the channel for more buffer overflow exploitation content. Hit the like button as well. It both helps out with the algorithms and really ensures that the people that need to see this will get it in their feed. So, yep, with that being said, I will see you guys in the next video.